Integrate 1 over x cubed plus 1. Okay, so we're looking at a rational function here. It's proper rational, but I notice that the denominator is a cubic, and cubics can always be factored at least once. Okay, so we'll go about factoring this. Now, I notice that it has a root of -1, which means it should have a factor of x plus 1. And if we need to, we can do a polynomial long division. I've seen this before, so I know it's going to be x squared minus x plus 1. That's pretty common factorization in math, but as I say, if we needed to, we could do a polynomial long division once we had one of these factors. Now, x squared minus x plus 1 happens to be irreducible. And if we wanted to, we could check. The b squared minus 4ac will turn out to be negative in this case. It's going to be -3, in fact. Okay. So we're going to need to set up a partial fractions decomposition. Okay. A over x plus 1, and then because we've got an irreducible quadratic here, we introduce bx plus c. Okay, so before we can continue on with our integration, we need to find a, b, and c. We're going to multiply both sides by x cubed plus 1. And we can see that we can get rid of the b by using x equals -1 here. Okay, so let's make a little note. We're using x is -1. Oh, there should be, yeah, I forgot the plus c. So this should have an x. There should be the x plus 1. Okay, so we can get rid of the b and the c by using x equals -1. So -1 squared is 1, minus -1 is plus 1, plus 1, 0, and 0. So 1 is equal to 3a, or a is 1/3. Now that we know a is 1/3, we could try something like x equals 0 to again keep the b away. And we'll have a times 1 plus nothing from the b, and then c times 0 plus 1, so that's just going to be c times 1. So 1/3 plus c is equal to 1, so c is going to be 2/3. Okay, we have one more to go. We just need to figure out what b is. Really, we could pick any value for x that we haven't already picked, so I don't know, something like 1 would do the trick. So 1 is a, 1 squared minus 1 plus 1, plus b, 1 plus 1 is 2, hopefully you knew that, and then x, well, that's just 1, and then c times 1 plus 1 is 2 again. So 1 minus 1 plus 1 is just 1, so we're going to get 1a, or 1/3, plus 2b, plus 2c, that's going to be 4/3. Okay, so 2b plus 5/3. Okay, so to get 1, b has to be -1/3. Okay, so now we are ready to integrate. Okay, so we get a over x plus 1 plus, and now we've got b x plus c, then x squared minus x plus 1 here. Alright, so this is going to be 1/3 ln x plus 1. That's not the hard part. We can also pull out a 1/3 here. Get minus x plus 2. The challenge, as always, is dealing with an irreducible quadratic. So there are a couple approaches. And we could use sort of building blocks, memorizations of, well, if you've got dx plus e on top and ax squared plus bx plus c, and you know it's irreducible, you can do this. You can memorize formulas like that. I'm just going to try and talk my way through it. Okay. So, well, what can we do here? Well, a good way to start this, I'm going to call this star. We'll come back to this. I'm just going to call this star. And our goal now is to integrate star on its own, and then we'll bring it back in. And that way we're not constantly dragging around this part of the expression. Okay, so what can we do? What can we do here? Well, I notice I got quadratic on the bottom. This thing has a derivative of 2x minus 1. So could I make that up on top? Well, certainly if we pull out the minus sign, divide by 2, and then multiply by 2, we can get something like this up on top. All right, multiply the top by 2, and then bring out the minus sign, but you can't just multiply by 2 for free, so you got to divide by 2. Okay, now, why bother with that? Well, now I can split this up as something that the substitution rule will easily apply to. Minus 3 times, and then we've got this expression here. Okay, so this part, very easy to work with. Substitute, let u be x squared minus x plus 1. So let's just do that part off on the side. So if u is x squared minus x plus 1, du is 2x minus 1. So we get a du over u, so ln of u, well, that's going to be ln of x squared minus x plus 1. Okay, so that's great. That part of this is solved. We will have to have this minus 1/2 hanging around. Okay, so we're going to have to be careful when we put this all together. Now let's focus on integrating 1 over x squared minus x plus 1. And again, if we wanted to, we could use some sort of formula. Okay, that is a good idea, because look at how much effort we're putting in, but sometimes it's good to remind ourselves how those formulas are developed, and that, you know, we don't have to memorize formulas. We're mathematicians. We can reason our way to a solution. Okay. Now, when working with irreducible quadratics, the typical example is that we know the integrals for 1 over x squared plus 1 look like arctan x. So what I want to do is I want to regroup things on the bottom here, complete a square, so that it looks like 1 over something squared plus 1. Okay, that's our goal. So what can we do? Well, let's complete the square. So how do you complete a square? We're going to need to add on 1/4 and subtract 1/4. And then add 1 here. Okay. So what does that have the effect of doing? Well, x squared minus x plus 1/4 is x minus 1/2 squared. And then minus 1/4 plus 1, that's going to be plus 3/4 here. All right, so that's looking good. We've got a square here. Now we can multiply top and bottom by 4/3. And the reason we would do that is to change this 3/4 into a plus 1. Okay, we like that because this is looking a lot more like the proper expression. Okay, the 1 over something squared plus 1. So we can pull out the 4/3, and we can absorb the 4/3 into our square here. And we can even multiply the 2 and get 2x minus 1. So 2x minus 1 all over root 3 squared plus 1. And now we can do a substitution. So let's let v be 2x minus 1 over root 3. dv is just going to be 2 over root 3. Okay, so we can rearrange that and say dx is root 3 over 2 dv. Now we can go ahead and substitute. Okay, so in place of the dx, we have root 3 over 2 dv. On the bottom, we'll have v squared plus 1. So now let's bring the root 3 over 2 out. We have 2 over root 3. And at long last, we've got something that we recognize. So this is 2 over root 3 arctan v. Okay. But what was v? Well, we said it not a moment ago. 2x minus 1 over root 3. Okay, we've managed to actually integrate everything. Now it's up to us to put it all together. Okay, all of this work here. Okay, so we're trying to integrate 1 over x cubed plus 1. All right, what did we have? Well, we had 1/3 ln x plus 1, and then plus 1/3 of our star. Okay. Plus 1/3 of star. So what was star? Okay, well, star was us trying to integrate this. And we took out a factor of -1/2. Okay, so we should add in a -1/2 in here. And then what else did we have? Okay, so the -1/2, this part here turned into ln x squared minus x plus 1. And then it was -3, if I recall correctly. Yep, -3, still inside the -1/2. -3, and then we had to integrate this, which we eventually showed was this. So we'll actually have that 3 and part of the root 3 cancel out. 2 over root 3 arctan 2x minus 1 over root 3. And then we'll add a plus a c in a moment. So 1/3 ln x plus 1 plus, well, I'm going to say minus 1/6 ln absolute value of x squared minus x plus 1 minus 1/6 minus times minus 1/3 is going to be plus 1/2 times the 2 over root 3. Well, the 2's will cancel out, so plus 1 over root 3 arctan 2x minus 1 over root 3 plus a constant. There we go. Integration all completed.